Hi, I'm here in the Rock and Sediment Mechanics lab, and I'm going to talk to you about how rocks are really like springs. Doesn't seem right, does it? Well, if you remember from physics or science class, springs obey something called Hooke's law. Now, all Hooke's law says is that the amount that the spring deforms or stretches is linearly proportional to the force that we applied to it. So that means that if I pull twice as hard, the spring is going to stretch twice as far. It's as simple as that. But are rocks really like that? Turns out, over some ranges of stress, they are. It's called linear elastic behavior, and it's critical to think about earthquake recurrence. Now, we'll get to that later, but first I have to prove that rocks are springs. To do that, I've got a large slab of granite down here on the floor, and under it there are some strain gauges mounted. Now, all these strain gauges do is let us measure how much the rock deforms by changing their resistance, and we'll measure that electrically. So we've got this piece of granite, and it's blocked up on the ends with some pieces of wood. Now then I'll step on top of it, and the granite will deform under my weight, just like the spring deforms when I apply force to it. Now the rock won't deform much, of course that picture was exaggerated, but we'll be able to measure it even though it's just a very, very small amount. Let's go do it. Alright, here are the strain gauges on the bottom of the piece of granite that we'll be using today to measure its deformation. They're hooked up in a circuit called a wheatstone bridge, and if you're curious about how it works, I encourage you to go look it up. It's a very interesting topic and a very useful circuit to understand. Alright, here's the piece of rock that we'll be using. As you can see, it's a large piece of granite, several centimeters thick, and not something that we would normally think of as springy. But we're going to step on it now and watch the response. Alright, so we're looking at the screen of the computer. Now I'm going to step on the piece of granite. I just stepped on, and there we can see the rock deformed under my weight. I can jump up and down a little bit, make it wiggle, and then I can step back off. And you see the rock went back to its original deformation state. Now you remember earlier I said that rocks were like springs, and we just showed that. But I also said it was related to earthquakes. Now, how could that be? How does that work? Well, the Earth's tectonic plates are constantly in motion. They're moving something like between the rate that your fingernails grow and the rate that your hair grows, so inches per year. Now, as they're getting pushed together, some of the rock is stretching, some of the rock is compressing. And all that stored elastic energy eventually has to go somewhere where the plates are locked together and just deforming. So stress builds and builds and builds, and then earthquake. The stress is released, the plates rebound. It's called the elastic rebound theory, and it's one of the simplest models of earthquake recurrence that we have. Thanks for watching, and I hope you found this helpful.